there are, of course, rules about limits, and, well, the limit laws give us pretty much all the important ones. Here, we have something that looks perhaps kind of obvious. So if you take the limit as x approaches a of some constant value, so in other words, if you graph this, it's a flat line, well, the limit is going to be that value. Now, if you take limit as x approaches a of x, that's equal to a. Assuming your function is continuous, which means that you can draw it all in one stroke, or say straight line, or whatever, the curve or line or whatever, it has some value, right, at a particular point, and from both sides it converges towards that value. That's part of the definition of a continuous line or a continuous function. You can just substitute right in. You can just take a, plug it into the equation, and assuming that you don't get divided by 0, well, there's your limit. If it is continuous. As in, oh, I have a chunk of function here and another chunk of function over here. And I look at the limit here, right in the middle. Yeah, no. Yeah, it's defined. It has a value, usually. But there's no limit. The limits converge to different values. What happens when you add functions? Wait a second, guys. What's the limit of 2x? So limit as x approaches a of 2x is equal to, well, limit of x approaches a of x and limit of x approaches a of x added together. So the limit of the sums of two functions is equal to the sum of the limits. If any part of either one does not have a limit, then if you're trying to find the limit of the sums at that point, it's not going to work. For example, the limit as x approaches 0 of 1 over x plus 1. I mean, we all know that limit as x approaches some value for some constant, so that 1 plus 1, well, that's just going to be that constant, so plus 1, fine. But what about the 1 over x? Well, as x approaches 0, that's undefined. It goes to negative infinity and positive infinity. There is no limit. For subtraction, similarly, if both of these limits exist, then the limit of the differences is just equal to the difference of the limits. So for example, limit of x squared minus x, well, that's just going to be limit of x squared minus limit of x for some x approaching a, or x approaching b, or whatever you're asked. Okay, so what happens when you multiply a function? Well, you're just adding a bunch of the same function together. This is just like way back when we learned multiplication and addition. So you multiply the limit of x approaches a of f of x by whatever constant you're multiplying by. And that's equal to the limit as x approaches a of c fx. So the constant times fx. Like say, limit of x approaches a of 2x. Oh, that's just 2 times, say, 2x perhaps? That would be 2 times limit of x approaches a of x. Well, yeah, okay, let's just write this all out. Of course, what happens when we multiply these things? When we multiply two expressions, wait a second, guys. This 2 here can be taken as g of x. So in a sense, this is the exact same as this if the 2 here was, well, g of x equals 2. So the limit of the products or the quotients is equal to the product or quotient of the limits. But there are restrictions, of course. First of all, both of these limits must actually exist. Second, well, here you can't have divide by 0. Dividing by 0 gives you undefined, so there would be no limit. Now here, if you take the exponent of some function and you find its limit as x approaches a, that's equal to the limit of the function taken to the appropriate exponent. The exponent can be a fraction. For example, if the exponent is 1/2, that means root 2, well, the second root or square root, as opposed to the cube root if it would say 3. Cube roots say x is equal to x to the 1/3. And this applies to the nth root as well. So this and this can actually just be written as one thing if we so felt like it. Now, for some of the questions we'll do shortly, we will actually write this step out. But as you get more experienced, often if you actually have the sum, the function you get from summing these two functions, actually continuous at that point, well, you just substitute a right in for x, and you're done with that. Well, okay, after simplifying, you're done with that. So, example 1. Prove the identity function f of x equals x for any value of c has this characteristic. Well, what we can do here is limit as x approaches c from the negative side, f of x is equal to limit as x approaches c from the negative side of x, which is equal to c. What about from the positive side? Well, c from the positive side of f of x is equal to limit x approaches c from the positive side of x, which is equal to c. This is generally taken as an identity, which means that you don't actually have to prove it. But in essence, the demonstration for why it's true boils down to something like this. So we end up with limit x approaches c of f of x is equal to limit, well, actually we should put negative and then, okay, approaches from the positive, and then equals limit overall of x approaches c of f of x. And then we can put lim x approaches c of x equals c. Yes, okay, a lot of teachers don't really appreciate having a row of equal signs, but that depends on the application. In this case, usually they're okay with it, more or less. Okay, say we have to prove that this is a case. Well, we could just say that for all x, y equals c. Therefore, lim x approaches c from the negative side of y is equal to c, and lim x approaches c from the positive side for y is equal to c. And therefore, well, pretty obviously, anywhere you approach, given that all your values are the same, is going to be that same constant. We should probably note down that this is equal to lim x. What teachers tend to look for and markers tend to look for is the limit from left hand side equals limit from right hand side, or left side limit equals right side limit. And we've given it to them. Okay. If all values are uniform, any limit will approach that same value. Approach that same value. Okay. Now, here, how are we supposed to use the limit laws here? We can break up the bracket, okay. What else? Hey, guys, there's no discontinuity here at x equals c. So, we have a smooth curve. Guys, if we have a smooth curve, just continuity in general, what do? We have the limit as x approaches c being just to substitute c in. So the limit of x approaches c for f of x is just f of c. So it's just plug and go, really. But, well, okay, it says use limit laws. Fine, let's use limit laws. Do what the question asks of you. Always. So limit of x approaches c of x to the third plus limit of x approaches c of x squared plus limit x approaches c of 3. And I think we probably all see where this is going. C cubed plus c squared plus 3. Hooray! Okay, what about this next limit? Is there a discontinuity involved? No, which means that the limit is just, plug in your number and go and evaluate. But since it says use limit laws, well then, let's use as many steps as possible to satisfy whatever teacher demands this. So limit of x approaches 3 of x cubed plus 2x squared plus x plus 1. And this is equal to square root of, I do realize that this is taking it to the extreme. And I do realize how overboard this is, but, well, it does say use limit laws, right? And why would a teacher ask this if they didn't want you to demonstrate that you know exactly what the limit laws are talking about? Okay, so plus limit x approaches 3 of x plus limit. I do realize this is a little silly now. Okay, 1. And depending on teacher, you might want to make your L's and 1's very different. My usual L has a little curl at the end, so I can get away with just straight line 1's. Okay. Here, what do we do now? We just substitute in. None of these have a discontinuity here. That's why we can just substitute this right in. Okay, so that's going to be 3 cubed plus 2 times 3 squared plus 3 plus 1 equals 27 plus 2 times 9 is 18 plus 3 plus 1. So 27 plus 3 is 30. 18 plus 1 is 19. And therefore, root of 49. And depending on region, you may have plus minus 7. But in North America, generally a square root is assumed to be positive only. Reason? Well, I don't know. It's just convention. So, many conventions have little explanation behind them, and I do know that in many countries it would be plus minus 7. So please make your notes as per your country's conventions. Now, for say polynomials, what happens is that we just plug in and go. Why? Because for polynomials, we are not going to end up with, oh, hey guys, this is discontinuous here. No. Rational functions, on the other hand, well, that has to depend upon the denominator not being 0 for us to just plug in and go.